Okay, so first we need to identify what kind of conversion we need to do. Do we need to do mole to mole conversion, gram to mole conversion, or mole to gram conversion? Okay, to know that, what we do is we analyze what is given to us and what is asking us to find. What is that given in this problem?
200 grams.
200 grams. Okay, 200 grams is a given, but we need also to specify the substance. The substance is NH3. Okay, so we um, so we identify the 200 grams as the given, okay, because it's the number related, it's the value related to a number. So we say, okay, this is our given, and it's asking us to find what?
Moles of
Moles of NH2.
Okay, it's asking us to find moles of nitrogen gas. So this corresponds to unknown, okay? Now, so what do we do after? We see what is given to us, you analyze that they're given to us value in grams, and they're asking us to find moles. Okay, so this is going to define what type of conversion you have to make. In this case, they are giving us grams, so the conversion is, the plan is from grams, okay, given, I need to get what?
Mole given.
Moles given. And from moles given, I need to get what?
Mole unknown.
mole unknown.
Moles of the unknown substance. Okay, so that's your plan. What do we do, or what do we need to use in the case that we have from gram givens to mole givens? Do we have to use molar mass, or do we have to use mole ratios?
Molar
Molar
mass.
mass. Molar mass.
So molar mass of what? The given or the unknown?
Given.
Given.
Of the given. Okay, now from moles given to moles unknown, what should I use?
Molar ratio.
Molar ratios. So with this, you have already structured your plan. Now all you need to do is start working on it. So let's start with the grams given. From grams given, I know that I have 200 grams of my given substance, that is NH3. Yes, NH3. So it says that I need to use the molar mass of the given. So I need to get the molar mass of the given. We did it in class yesterday. But just in case that you still don't know how to get molar mass, this is the procedure that you do. Molar mass. We have a substance that is NH3. Okay? Okay, okay. NH3. So we're going to add one nitrogen plus three oxygens. Three hydrogens, sorry. Three hydrogens. So we add one nitrogen plus three hydrogens. In total, the molar mass is 17.0297 grams per mole. I'm reviewing this because you always have this doubt. Miss, how can we turn this into a fraction? How can we turn this into a fraction? Very simple. Imagine a fraction a over b. Whatever you have to the left represents the numerator. Okay? In this case, to the left, you have the grams. So the numerator is what is on the left. Okay? So you write it as 17.0297 grams, and the denominator is the right side. What do you have in the right side? You have just mole. So B represents your number of moles, comes down. Okay? And because 1 is a number that likes to be invisible, you just make it appear over here. So you say that the molar mass can be expressed as 17.0297 grams over 1 mole. Or you can write it in the other way. In its reciprocal form, you're going to write it according to the cancellation process. Okay? So because I'm talking here, I forgot, because I'm talking about ammonia, I'm going to specify the substance. This is important because when you cancel units, you need to know exactly what you're canceling. So this is in 1 mole of ammonia, I have this specific amount in grams of ammonia. So I say the reciprocal way of this fraction of this conversion factor, then it's going to be grams were in the top, now my grams are in the bottom. Mole was in the bottom, now it is in the top. I'm gonna call them A and B respectively. So let's go back to the problem. Let's go back to the problem. So let's follow the plan that we already structured. From grams given to moles given, it says I need to use the molar mass of the given. I have my molar masses right over here. What molar mass I'm going to be using? A or B?
B.
In order to get rid of grams of ammonia. Which one I'm going to use?
B.
B. That is correct. Okay, I'm going to use B. The reason is because grams of ammonia is in the bottom. And in the top, I have 1 mole of ammonia gas. With this, I get rid of grams of ammonia with grams of ammonia. But the problem is not asking me moles of ammonia. It's asking me moles of nitrogen. That means that the process isn't over yet. So I already did this, and I need to use to do my second step, which is from moles given, moles of the substance given, that is ammonia, to moles of the substance unknown, that in this case is nitrogen. So it says that I need to use molar ratios. What is the molar ratio between the two? What am I going to write in here?
5 mole
5
of
moles?
N2.
4 mole NH3.
Okay, 5 moles of nitrogen up, and below I'm gonna write the 4
Moles of ammonia.
moles of ammonia. With this, I finish that problem. I just make sure that I'm canceling the right units, mole with mole, ammonia with ammonia. That's why it's important. And then in the calculator, we perform everything. How much did you get? Remember, everything is
14.68 moles
14.68
nitrogen.
moles of nitrogen gas. So this is the whole procedure, but sometimes this procedure involves other inner procedures like molar mass calculation and, in this case, the mole ratios. The mole ratios that we did were based on the given and the unknown. The mole ratios, you get them from the given, that is ammonia, and the unknown, that is N2. These are the two coefficients. Those two coefficients are the only two numbers that appear right here, 4 and 5. So that's why we guys, that's why I always tell you in class, try to be organized when you analyze your process. When you are presenting your process, try to be organized. In this way, it's going to make life simpler. Okay? That's why here I use colors. It's pretty simple to use colors. But at school, I still haven't figured out how to use the iPad there. So that's why I'm using, but I'm also using the markers. And I hope you guys find it very useful to do things like this. I'm not saying go and buy a highlighter or many highlighters. I'm just saying, guys, be organized. If you're organized, your procedure is going to look not just clean, but also when you study, it's going to be better for you. This procedure of the molar mass, it is an implicit procedure that you have to do for this. So stoichiometry is pretty simple, but it also takes time. Please do not forget your periodic table. Next week is an evaluation week. I will be evaluating physics and chemistry. And what's coming in physics? Well, SOHCAHTOA and vectors, okay? What's coming in chemistry? It's coming naming acids, compound formation. And because I also need you guys to practice stoichiometry, I will ask you conversions mole to moles only, okay? So those are going to be the topics. I'm going to send a message in classroom for you to know. It's 10 points, so you better do a nice job. From the exercise that I just did, do any one of you have a doubt